So thank you all for coming. Much appreciate your attendance. And before we start, I would just like to pay my respects to the Jagera and Turrbal people, traditional custodians of the land on which I am at the moment in Brisbane. And also the Waka Waka and Bundjalung nations, the traditional stewards of the land out near where I call home and where part of this work has been developed. And also the Gubbi Gubbi and Yagara peoples up further north where I make my home these days. And I'd just like to sort of reflect for a minute on that, if this seems like a strange or perhaps uncomfortable way to start a session such as this. I know it's a bit non-standard protocol for a technical deep dive, but I'd ask us all just to sit with that feeling for a minute and just sort of examine why that may be the case. Because the work that we're talking about today, this is not independent of culture. This work kind of is culture. And it's important to be in reality about the culture that we bring to the table ourselves and the culture that the work is gestated from. In this case, it's coming mostly from Western institutional backgrounds, enterprise and academic environments. And this is important because if you're on this call or you're listening to it, or if the concept of McDonald's means something to you in your reality, then you're some degree intertwined and subconsciously enslaved to the mindsets of colonialization that have created the situation that the world's in at the moment. And Indigenous cultures are those people that we have who think differently and live differently, and most importantly, know how to take care of this planet in ways that we in the West have largely forgotten. So I just really want to underscore that point before we begin the session, because what we're going to discuss today is fundamentally a technological system, I should say, for manipulating the fabric of reality. So without guidance and without varied and diverse collective scrutiny and input on this, it's just as likely to lead to negative outcomes as to positive ones. You can use works like these to run extractive capitalist societies that undermine people's basic human rights just as easily as you can use them to create socially and environmentally regenerative patterns. And so a good guideline to adopt in this work is that those who are to be affected by the outcomes and the technologies must be the ones involved in designing and deploying them. And we can talk perhaps at the end about some of the ways that we're working in and towards that with this project and ones around it, if people are interested in talking more about it. But for now, I think there's maybe a few too many people here to take turns doing introductions. So I might just post a little introduce yourself prompt in the chat and ask you to fill these things out. We'll harvest the chat log at the end and put it in the video description so that everyone out in the wider world knows who was here. And when you speak for the first time, feel free to jump in at any point. I'm totally open to cross-cutting and questions. Just say your name so that people know who's who. So I'm Pospy. I use they, them pronouns. You can find me at my website, which I'm sure will be in a link on this. And the project obviously most heavily involved in at the moment is Holo-REA. So I'm going to just share my screen because it's got a bit of an outline on it, and that'll help us all kind of get a sense of where I'm going with things. A bit of protocol stuff before we start as well. Just if someone wants to take it upon themselves to monitor the participant list for hand raises and let me know if anyone's got hands raised when I'm talking. I probably won't have it on the screen all the time. And if you feel like I'm kind of moving on and you've got a pressing question about something I was just discussing, then please do ask me to cover it off. I'm also going to ask people, myself included, to try and avoid jargon and stay out of domain-specific language that isolates people and prevents comprehension. So feel free to jump in and ask for clarification on any acronyms or concepts that are coming out of this. And we've done the say your name part. So I'll just start with just a little bit on Holochain architecture, because I know we've got some people here that are new to Holochain coming from blockchain backgrounds and other things. So my really quick summary would be that Holochain is just a data replication system, and I am enjoying that as an experience after having built blockchain stuff where you always kind of have an economic paradigm baked into your database. And so just having something that replicates data is very refreshing. But that also means that by itself it's inert, and so when you want to start building things like economies and coordination systems and user profiles and identity systems, they all have to be built as applications on top of Holochain. They're not part of Holochain core, So there's sort of an aspect of modularity there that makes it quite interesting. So you can, take the identity module that it ships with, swap it out for something that uses Chinese cryptography if you need cryptographic identities and public keys that are legal in China. And you can swap those out and use them interchangeably. So there's all this kind of compositional stuff you can do, which I'll get to in a bit. Other things I would say about it, it's entirely peer-to-peer, and by that I mean every network participant is equal to every other, so there's no mining, there's no you have to ask someone else to do something for you. It all just happens, in fact it all happens locally on your device first and then is replicated out to people if you choose to share it. There's also no running costs involved. There's sort of an approach to optimization here that means that all the machines in a network are actually collaborating and doing sort of an efficient slice of the calculation rather than more the blockchain approach where everyone is running every transaction themselves to check that nothing's going wrong. And so because of this, there aren't really any running costs, which means that in Holochain apps, you don't need complex incentive structures really like you would in other distributed systems to date, because only the soft incentives of wanting to use the app are really necessary because it's kind of free to run the app, so you don't need any other reason to do it. On a technical component, so it's not so much that Holochain is a network, it's Holochain is a framework for building distributed networks. And a network in Holochain is basically just a set of WASM code that runs on a machine, WASM being, WebAssembly, a set of standards to let you run fast code in your browser, basically. And so you take up a bundle of code that represents all the business rules in a Holochain network, and you get a hash of that, and that's the network address. So you get this way that you can actually deploy Holochain networks into Holochain networks and start this kind of recursive unpacking of bits of code that describe collaboration spaces that people share. And there's also, probably too technical to dive into for this talk, but the ways that data integrity and things are handled in that system are basically through the idea of an immune system. So whenever you interact with someone, you're kind of witnessing all the headers of each other's change, each other's chains of data that you've written, and effectively every time you witness someone else's, you're kind of sealing it and saying that you've witnessed it all, which means that if you find someone else has witnessed different history, you can very easily detect tampering with data, and you just block people from the network when that happens. So there's sort of there's a different mode of resilience here to what you're kind of used to with consensus and things in blockchain. There's no such thing as a 51% attack, really. It's just that if you change the rules, people detect the data doesn't validate, and you get banned from a network and sort of fork yourself off automatically. Does anyone want to ask any other questions about Holochain in general before I keep going? I'm not seeing any hands. I think we're good. All right. I'll keep soldiering on. So Holo-REA, I want to give a little bit of a background on Holo-REA as a project. So this is an implementation of what's called a contributory economic system in the ways that it's been used before, but an economic system being built as an application layer protocol on Holochain. So again, back to the fact that Holochain just replicates data. It starts off inert. If you want to do something economic, you're going to need to build an economic system on top, which means that there could well be a plurality of different economic systems on Holochain, that some that may interact with others and some that might not. My aim with implementing this is actually to take some state-of-the-art work that's been done before and move it into the current distributed systems paradigms. So this is kind of an older diagram that I put together some time ago to describe this, but just to call out that there is an older semantic web grammar that's the ValueFlows project. These are GitHub links, by the way, so you can find these on GitHub if you want to go deeper. And ValueFlows as a spec has been around since about 2015, and it comes out of this whole domain of thought known as REA accounting, which is, as I said, a bunch of, it comes out of enterprise resource planning, actually, some of the background for those that know what that means. But it's been a school of economic thought since the first papers in 1979 were written on it. And the idea is essentially that the wording for it would be an upper ontology. So the idea is that you can create a formal grammar, a language that describes everything in a domain of knowledge, in this case, resource coordination problems. And so ValueFlows is this domain model that can conceivably describe any kind of interactions that human beings might have with the material world, but also with the immaterial world in terms of their skills and resources and shares in companies and hours of labor and all kinds of things. Then coming out of that in more recent times has begun an effort to create a GraphQL standard matching or based on the RDF standard. And that's the specification that we're building to with Holo-REA. But all these works all come out of these older systems. Django REA was the original version that a group called Sensorica created around a similar era, I think 2015, 16. So these are all kind of client-server implementations that have been tried and tested in the field and used in numerous contexts. And now there's actually a Scuttlebutt implementation for those that know the Scuttlebutt network that's been toyed with, and then Holo-REA is the Holochain implementation. And I also kind of wanted to talk briefly about the idea of domain-driven design with that, because it's a term that I only really came to recently. But essentially, it's the idea of having this split between the domain model, like this formal grammar of resource coordination in the case of ValueFlows and REA accounting, and the implementation. So it helps with accessibility, because it means you can start to have people contributing to the specification who are not technically inclined to be writing code. And it means that you get a lot of cross-project collaboration, and these people in Scuttlebutt, but also with some of these UI applications particularly, we're finding that there's a lot of work between projects that, just because of the fact of us all sharing a specification, we all tend to benefit from as we go. So I'd really encourage those who are working on Holochain apps, but any apps really, but working on apps that aim to build protocol and connect broadly to other applications and really start to create interconnected webs of data. Domain-driven design is a really nice way to approach that, because it makes your protocols very clear to others and how to integrate. And there's also a couple of broad project goals here. There's a few on our wiki, which I've sort of discussed briefly, but they're a bit premature to talk about in detail. The two that are sort of relevant at a technical level here are modularity and accessibility. Modularity, I think, is pretty straightforward. It's really the case that thinking about this model as a domain-specific language and a grammar for resource coordination, bringing it into a situation is almost sort of an imposition, because you're bringing in this entire idea of how resources move and the ways that we should describe the relationships between them. And there's a certain amount of theory that goes with that. So a lot of work has been put into making sure that all the pieces that build this up are as small and decoupled as possible, because it leaves room for agreement, essentially. And it means that we can build an agreement module that lets you manage agreement between things and refer to it loosely in other modules. And if people want to add different rules on how agreements are formed or change the structure of agreements, they can do that and plug it in without having to change the entire system. So we're really hoping for a lot of innovation and experimentation, even in different components. And accessibility, in terms of the code, through this process, it's really been about just writing the simplest code possible to get the job done for me. Like the development of the works needs to be as accessible as possible, as well as the use of the works, but also the governance of the works. And that's something maybe we'll talk about a bit later. And they're all sort of related in terms of how they cascade into play. So with all that background information in mind, let's jump in and start looking at some code. So this first section, I think the context really is talking through what's required to create systems that use the economics of REA and the kinds of ledgers that are provided by the framework that we have now. And so there's kind of a couple of layers to that, depending on how deep your integration wants to go. And again, back to the accessibility, a real goal here is that with this extreme modularization of components within the framework, actually there's room to experiment with quite a lot of complex social architecture just by different arrangements of those modules. and this all happens at the UI layer, and it all happens through GraphQL. I'd be curious, actually. I don't think we have done the thing yet, but if you all click on participants in the bottom of the screen, you should get a little box that lets you raise your hand with a button somewhere. But I'm just curious to get a show of hands as to those here who have used GraphQL before, or if people are entirely new to it. I should have probably coordinated some how to use Zoom's hand signals earlier. So we'll keep talking through it anyway. So it's, oh, my bad, didn't need to do that. GraphQL essentially gives you, this is actually a model of, or a visual browser of the components of ValueFlows that have been implemented in Holo-REA so far. So this isn't all of ValueFlows, this is just a subset of the schema. And back to the modularization stuff, when you look at the code and how I'm trying to lay it out for the actual GraphQL specification, you can see in, actually, in this mock server here, I'm only pulling in these modules of the schema at the moment. So this is also a part of modularization because people, this is quite a big system to implement an entire implementation for, and people may only want to do bits and pieces. And in fact, there's a collaborator at the moment who's not planning on implementing agent because he's got other systems that deal with identity. So being able to just pass a list of module IDs to create a GraphQL schema is something that I've done a fair bit of work on in decomposing the old previous gen systems that were quite big monoliths. And so when you look at it, you've got things like there's observation records where you're looking at these are the data types that make up an actual event ledger of all the events that have happened in the economic network. So you've got events, you've got resources as sort of representations of the events. And this is going a bit all over the place here, I'm afraid, but sorry. But this is also a key part of the model because and an ideological position to take in the same way that all of Holochain takes this agent-centric idea that there is no objective reality and that everything that's entered is in the context of a person observing it, so it's all sort of subjective and open to opinion as to the trustworthiness of the agent who put it there. And this is a very similar narrative with ValueFlows. The fact that when you start looking at the APIs of this, you'll find that there aren't really any ways that you can manipulate resources directly, because the expected way that you manipulate resources is by logging events. And you don't, typically in an accounting system, if you go and you put in a record to say you took $100 at the end of the day, if you find out that's a mistake, you don't go and delete the record, you put in another record saying negate that $100 and here's the reason why you did it. So there's some things to do with record keeping and the integrity of history involved with this. But also some core acknowledgements of the reality that the computer system is not reality. It doesn't actually create, the model of what is true. Everything is just something that's been said by an agent, and we derive reality from that. And that's really key. When you get into the actual the front end UI layer code, in a lot of cases, because of this modular nature, this is going to be most, if not all, of what a use case for REA might be. It's just building some applications to deal with it. And this shrew map is one that's actually been built for a previous generation for the old Sensorica work of the system that I'm in the process of porting over to the new one at the moment, just as kind of an experiment. But I just kind of want to call out some things here, which we got here. Yeah. The queries that come through GraphQL, the syntax can be a bit interesting for people when they first get used to it. Where are we here? Get agent processes. So this viewer stuff is part of the old system, which we don't do anymore. But the short version is that you essentially create this sort of nested query structure that lets you pick the relationships between objects and fairly intuitively describe things. So this one here is to get all the processes that are active that someone should care about. And you can see it starts by getting your own agent, your ID and your name and sort of the stuff to compose your profile, and then starts looking at edges to find all the processes related to you and what plans they might be a part of and how many commitments are active in all that process and all this related data, which is part of the ValueFlows model that I won't go into great detail today. But the nice thing about GraphQL when you do all this is that because it's a very tight schema binding between the front end and back end, it's very, very difficult to make mistakes. And when you do, you will tend to get very readable errors about what's gone wrong. I sort of broke the toolchain this morning, so I won't tinker with it too much, but sort of to say that, you know, putting the wrong names and things like that, it will figure out immediately. And just to sort of show some of it in action, this is a query browser that's a stock standard GraphQL query browser that I've spun up just to point at a running Holo-REA backend. And you can see on the side here, there's this documentation explorer that actually has all of the types and edges between them. So if you go and start looking at agents there, you'll see that it has these relationships between agents and events and so on. And but there's some good features about it in that when you start typing, you know, you've got autocomplete based on the schema you've written, and you can do these sort of very simple ways of retrieving information. And if things go well, there you go. It just pulls the fields, and you get a JSON structure in response that mirrors the query structure effectively. And you know, we can also do things querying them out, and yeah, I just kind of wanted to show that as yeah, it's probably something that if you've used GraphQL, you've seen a lot before, but having this kind of intelligence between the front end and back end is a real help. And it also flows in, before we move into testing. So yeah, in terms of GraphQL, there's front end libraries for all kinds of stuff. If you go and look on NPM, you'll see heaps of things, but there's you can pull this into servers if you want and run it through Express stuff. I wouldn't recommend that, because then you're looking at essentially creating centralized points of failure in your architecture and your infrastructure. But there's sort of plugins for, you know, all kinds of front-end frameworks that let you do these bindings between your view layer and your backend. So people are doing it currently on React. Someone's doing Angular. I think there might be one or two Vue projects ongoing. It's really up to you, your front-end choice. GraphQL doesn't lock you in too much. It's just a case of getting your head around the GraphQL integration part, which actually, to show you a brief version, it's usually not too onerous. So I'm trying to remember where it is in this app, though, probably in here. Yeah, so we pull in this module here, which is on NPM if people want to check it out. And this is, the way I've set this up is that it all happens within the browser. And some other GraphQL stuff I've seen on Holochain does talk through an Express service first, but again, you don't kind of want that as having to run a little node in the middle. So basically this module just exports the full schema that's already bound to Holochain, which I'll talk to in a second. And you pass this in, you make a link, and you create a new client to service your queries. And that's more or less all you do. I think probably in index or something will be where it's actually injected here. Yeah. So if you're familiar with React, you've probably seen this pattern with other things. Material UI has a provider, or actually that might be it there. But yeah, so you sort of take some React components with some config, wrap the root of your component tree in it, and then you can just write queries. And the queries themselves, you know, there's a component that you pass them to, and you get a bunch of data back that tells you if it's loading, gives you any errors, the query data, and some methods to requery. So the integrations are there and pretty straightforward to use. And I did also want to talk a little bit about ValueFlows UI, which is a kind of side project that maybe is starting to ramp up more now that we're at the place where the back-end stuff is largely finished and we're moving into front-end. Svelte is one of the more newer front-end frameworks that I've seen people getting excited about. And I've sort of done some digging in Svelte, and it seems like it wouldn't be terribly difficult to get Svelte to compile in a way that could talk to every front-end framework. So again, with the modularity and the accessibility, that's a big design goal for us as trying to be an inclusive toolkit. We don't want to lock people into having to use React or Angular or anything in particular. Svelte, as it stands by default, is designed to just generate normal standards compliant web components. So you could conceivably use components that we build for Holo-REA just in static HTML pages and not need really any other development expertise, which would be really cool. But yeah, ideally you'd be able to bring the same component into any different front-end framework and not have to worry about compatibility and stuff. So let's jump into, well, we've kind of jumped into the GraphQL a little bit already. The things to sort of show are that the actual, so VF GraphQL on GitHub under the ValueFlows org is the domain specification for how all the queries should function. And I just kind of want to show you, so this is some of the schema building logic, but the module actually exports a few things. This one and this one can be useful because you get a lot of GraphQL tooling that actually wants a string of the schema instead of a pre-built schema object. And I found that you can actually just call print schema on the output of build schema and it will work. So there's just a little bit of adaptation stuff there. But the other cool thing is validation. And again, just kind of leaning on GraphQL's tooling here. I can use the implementation, also I can use the reference schema as a validator for any implementation. So I can point this at any other GraphQL schema or any GraphQL server that's exposing queries. And I can tell exactly whether it complies to the spec, which is really handy for when we start building multiple backends. You know, back to this diagram where we've got a few different backends that are trying to speak value flows. Having them all coordinated in a way that I can actually run a validator to see if they're compatible is really, really cool. And I do plan on kind of breaking that validation up in future into smaller, more modular pieces, so you can just kind of validate, does it have the agent module, does it have the observation module, without having to validate the whole system. The other neat thing about the, some of the GraphQL tooling is that there's a package called, where are we? GraphQL CodeGen. And there's some interesting stuff you can do there, but I can actually generate type definitions from the GraphQL schemas. So the schemas in here, let's look at observations, say. This is the standard GraphQL query language. It's intentionally a very simple language, which can be awkward because it kind of duplicates some things that you prefer not to. But this then, when I run it through the GraphQL CodeGen, it generates me a bunch of TypeScript types that map to the GraphQL types and a bunch of flow types if you prefer flow. It can do reason, but I haven't actually gotten that module working. Anyway, so this gives you typing information, which means that then when I get to, so this VF GraphQL, remember, is protocol level specification. If I go into the Holo-REA repository and look in modules VF GraphQL Holochain, which is where the Holochain specific implementation bindings for the specification are, this is getting a bit of a mouthful. So if I go in and look at that, you can see that actually I'm requiring the specification itself. And in fact, when you make schemas with GraphQL, you provide it the type defs and the resolvers separately. So what this means is that the reference specification is not only the reference and a validator, it's also the implementation. So you're always perfectly in sync, which is really, really cool. And so if you do get into learning GraphQL, you'll learn about resolvers, and essentially it's just a bunch of functions that mirror the schema, and that they are how GraphQL figures out how to fetch data from your server or backend. So in the subfolders of here, there's mutations and queries are kind of the top level pieces of GraphQL. So you've got a bunch of root queries where you can query stuff, makes sense. The mutations are all, like say if we look at economic event here, you've got create economic event, update and delete. It's all fairly standard mutations in terms of RESTful endpoints. And if you look at the queries here, you've got, you know, economic event will read you a single one, all economic events read you a multiple one. And again, looking at this, it kind of maps to these types that you can see here, and it's all generated from the same source of truth. But these basically just need to match up, and it'll run this logic and fetch things. And so this is where the bindings into Holochain start, because you'll see here, well, two things to note. One is I'm importing those types into this code, so I'm using the generated types, and I can know and have error handling in my TypeScript files if I'm not matching the schema. The other one is that this connection module here, this connection file, is got this zone function in it, which is where I actually bind to the Holochain pieces. And for those new to Holochain, there's sort of a concept that you have, in terms of accessing Holochain, you have the Holochain conductor that runs locally, And through that conductor, there'll be a bunch of, so the hierarchy is you have these top level things called DNAs, which are all independent networks that are totally isolated unless you make them talk to each other. And then within a DNA, you have a bunch of zomes, which are kind of like small reusable bits of functionality that are fairly independent and loosely coupled. And the key thing about when you would choose one or the other is basically it's a DNA if it's got its own state that's kind of global to the whole system. But if it's got state that you want to add to something else, and you might want to add it in a bunch of different places, then a zome is what you want because the zome has its own state. So say, you might have a mix-in zome that does some timestamping functionality or some signing functionality, and you place it next to the one, the zone that handles economic events so that you can then have the economic events do signing stuff. But you want all the data about how those events are signed to be stored with those events in the same network space, which is why it's a zone. You don't want it stored in another totally separate network that's not related except by people that know it's there. So when you look in connection, you can see this is kind of where the front end bottoms out. This is where I'm including the standard Holochain web client, which is just an RPC interface over WebSockets that talks to Holochain backends. And there's sort of some, I've got an environment variable there that I use in development because I talk over a port explicitly. But when you're running it from the conductor, it just kind of magically figures it out based on some predefined file paths. So this will just know how to connect to Holochain if it's run in the right context. Oh, and while we are talking about GraphQL and things, a good place to look in the Holo-REA repository to talk about, to look at GraphQL queries is in the test folder, because a lot of the tests in here are written in GraphQL. So say this one here for conforming resources, I'm basically, you've got a player helper and it injects some stuff that lets you run GraphQL, and then it more or less looks like this interface in terms of what you're writing. So you pass a string for the first one, which is sort of the operation to perform, and then there's a JSON object of all the parameters to substitute in, and it just follows the standard GraphQL spec. So you get these kinds of queries, which can be a little bit verbose, but I find quite pleasant to read compared to, if you look in this core architecture folder at some of the older tests, you've got all these calls, which is calling into the Holochain RPC stuff directly, and it's just kind of a more low-level interface, which I think maybe touches on some of the stuff that I wanted to mention about GraphQL as well. It's these kinds of queries, they give you pretty good error handling in the tests as well. If I break the queries, I'll get an error saying the query's broken. If there's errors in the actual implementation where I'm writing the resolver code, so back up in, modules. So if there's any errors in here, they'll kind of bubble up through the tests and you'll tend to see them as well. So it tends to be pretty tight. I feel like I'm missing something here. Oh, yeah, I mentioned it on the description for this as well. It kind of comes with the domain-driven design part of this as to why we're doing all our integration tests through GraphQL, or why we're doing integration tests at all. It's really mostly an artifact of where we're at historically, more than anything else. There's a great talk called Integration Tests Are a Scam. I really recommend people check out. It's not that talk, but Destroy All Software has one called Boundaries, I think, which is one of the best, yeah, this one, Boundaries. One of the best talks on software architecture you could ever watch, but he also runs through why integration tests are a scam, and it's essentially this thing of, as you're zooming more and more out from the center of your code and trying to run a test, it affects more and more lines of code exponentially until you're kind of testing things to such a degree that you can't really change anything anymore without breaking the tests, and the tests start getting in the way rather than helping. But given that Holochain has been in a state of flux, the internals have sort of been shifting, and we're building to this protocol domain, having our integration tests at this layer, we think, has been much more useful. And it also means that when we're said and done here, because this is all testing against a GraphQL schema, we can actually take all those tests and use them on different implementations that run on Scuttlebutt and Django and other things, and use the same test harness. So that's cool too. And yeah, tests are also example queries. So there'll be more as the days go on and we start adding kind of more business scenario use cases. But there's a few in there that are a good place to look as to how the model works. That's sort of all I had for the UI layer. Do people want to talk about anything in particular with UI or go deeper on particular pieces before we move into the back end bits of this? Lots of silence. Okay, cool. I'm taking all this quite. Yeah.
Sorry, I didn't want to disturb. I'm late, so listening in. So I'm sorry I missed the first half.
That's all right. Is there something in particular you'd like to have answered that we haven't covered?
Well, I'm really interested in this whole idea that you just said, the whole idea of frameworks and backends and frontends, and so it's really the decoupling the storage from the capability, and so I'm very interested how it is done in Holo and the whole thing. So I'm just listening in. Yeah.
Okay. Well, you came to the right place and the right time then, because that's.
Well, no, I'm late. Sorry, but yes.
The next bit we'll dive into the Rust stuff. I'm just going to.
I'm wondering if you could maybe give a quick high-level overview of just what is REA. I know it has to do with accounting, but it's not the same as.
Yeah, sure. A bit of looking at the protocol. It's a new way of looking at accounting that kind of merges two fairly common ways of looking at systems. So I'm just going to pick out process here because there's kind of two parts to this. That in the REA domain and ValueFlows, that we kind of have the opinion that these two things combined can model everything that you could conceivably do. So the process is kind of this item that gets a bit downplayed in ValueFlows because we talk about the flow elements, which are events and commitments and intents a lot more. But the process is sort of a central thing where it all hinges off. And you can see with the process here, you've got inputs and outputs, which are economic events. Don't quite want to skip over there. But you've also got previous and next processes that might be in a sequence. You've got an ability to trace and track the events that came into and out of the process. But beyond the events, so there's sort of these three types of records here that are, all much the same, but just looking at it different temporally, I guess. So the economic event records things that have already happened in the real world, and it's observing that an event has occurred. Then you have committed inputs and outputs mapping to the event inputs and outputs, and these are things that haven't happened yet, but they're going to happen in the future because everybody who's involved has committed to making them happen. And then when you get all the way into the future, you have intended inputs and outputs where the record type is an intent, which is where no one's agreed to do anything yet, but someone has said that they would quite like something to happen. So it gives you a way to forecast what you want to happen, and it gives you flexibility because things don't always go to plan. So the intent that you've originally set out may not get met the way you expected, or it might be oversatisfied or undersatisfied, or different things might happen for it to be satisfied in different ways. And the model, because of the separation of these three items, lets you account for all of that. But the key thing about process, of course, is the inputs and outputs. So in ERP systems and in a lot of domains, really, like there's a concept in chemistry that they call Petri nets that I've not found out about not that long ago, which is essentially the same. And it's just this idea that you can break down any system into this model of input, process, output. And so in REA systems, it's usually like you've got some input into a process, and the input's going to be a bunch of work that people need to do. It's going to be the resources that you need to do it. So maybe it's a bunch of wire and some circuit boards that you need to construct a wind turbine. And the processes build the wind turbine, and the outputs at the other end are going to be the built wind turbine and maybe some rubbish that you need to throw away. So that's kind of one part of the model that lets you describe supply chains that permute things into other things. And then the other main part is just between economic events and the other record types themselves. And so there's these actions which describe all the things that economic events can do. and if I go to the official website, it's probably the best place to see the list of actions. It's quite interesting because they used to be things that people could customize, but no one ever really customized them. So they're no longer customizable, with the idea that if people think up new actions, then what they're really thinking about is, here we go, is new ways of organizing. And so people that are trying to organize in these ways should kind of come together and have a discussion about what this new way is, and if it's actually a new thing, or if it's new language being applied in a different way. Yeah, so you have actions here. These three: transfer all rights, transfer custody, and transfer. And that's where you've got this exchange model that complements the input process output model. So you can do things that are mutating objects into other objects, or resources, I should say. But you can also do things that are just swapping resources between different agents or different inventories. And you can see some of them, like you've got transferring custody versus transferring the accounting and ownership rights. So there's ways that people in economic systems think about their ownership of resources that are sort of managed within the vocabulary as well. Does that answer your question well enough for the moment, Jim?
Well, I'm listening. I'll keep listening. Thank you.
Cool. So next, I'm just going to mute people. So we'll get into the back end a bit here. I won't do the hands again because I didn't really do the hands well the first time. But I will take it as given that there's a number of people on this talk that have not written Rust before. And I was one of those people when I started this process about a year ago. And I won't mislead you, it was difficult. As someone who has never written an ML-derived language before, which is probably true of most programmers, I would say. I think most of us grew up on JavaScript, Java, C, C++, all those things. They're all algol-derived languages that come from a particular way of thinking. And it's just a different way of thought. It's really kind of the switch between imperative and functional programming and taking it on board. Although, Rust is a mixed paradigm thing, as they say. I also won't lie, I mean, in the middle there, I came very close to just giving up entirely and having an entire change of career. I was just like, I'm not a programmer anymore. I can't even deal. Like, this is too difficult. I'm not getting anywhere. And I think a part of that for me was I found the Rust book. Like, people, when they say, if you want to learn Rust, read the Rust book. That's all you need to do. And I found the way that they present the material in that book a little bit misleading, in that you kind of read it and you come away from it with this idea that, hey, Rust is like this really elegant, like high-level functional programming language. It'll be a bit like writing high-level JavaScript or maybe even Haskell, and I can do cool functional stuff. And then you get to using it and you realize that actually it's a very low-level language that is very tightly constrained about the things you can do. And it really, it's not a high-level language that's going to be easy and convenient for you to do stuff. It's a low-level language where the memory handling semantics of the language are built into the type system. So the type system prevents you from making memory handling errors. And it also gives you really low-level access to stuff that you don't get in other languages. So one example that I hit early on, because one of the first architectures I tried for this was kind of a reducer-like architecture. And if you were doing that in Swift, it would kind of be easier to do because of the way that Swift manages closures. You can make functions and they're actually held on the heap and there's a pointer to them and it passes the pointer around for you. But Rust doesn't do anything for you. If you make a closure, it's going to be stack allocated and you have to deal with it unless you explicitly go and put it on the heap. So you end up writing all this quite awkward code just to put things on the heap and move them around efficiently. And it quickly kind of gets a bit hairy, and it's sort of like writing a combination between C and Lisp, I would say, is kind of most what it feels like. It's not that those high-level conveniences aren't there. It's just that you don't use them a lot of the time, and when you do, you'll find them sort of in unexpected ways. In fact, one to show you, I'm not sure if I will be in the grid actually. Probably here. So there's some logic somewhere in here that does a bit of deduplication on an array. It's in here. May not find it. It's all right. I guess I was looking for, just being able to sort an array and remove duplicate values, and there wasn't like a nice, easy way to just kind of chain that onto an array. And I found that the way I actually had to do it was I had to make the array mutable and have another statement to sort it, and then another statement to remove the duplicate values. There wasn't any kind of easy way to do it all, like you would in JavaScript if you're used to writing JavaScript that way. And then you kind of look at it and you're like, oh yeah, well, this is the way that Rust is. Like, that was a little bit awkward to write, but what I've written is about as memory efficient as it could possibly be. Like, it's using the same array, it's not allocating any new memory, and the algorithms that it's using are probably highly efficient because that's a big design goal of Rust. Anyway, I won't go on about Rust too much more. Just to say that with the goal of accessibility, it's a bit of a difficult pill to swallow at first, because there's a learning curve there to getting your hands on the language. And so again, to the goals of this project being to write the simplest code possible to get the job done, the goal was really, how do I make this in a way that people don't have to know too much Rust syntax to be able to use it? And that's a work in progress. It's getting there, but it's by no means complete. So zomes versus DNAs, we've talked about the difference between the statefulness there. And I'm just going to jump to VS Code and show you through some of this stuff. So,
can I ask a quick question, Pazzi?
Yeah.
Maybe you'll get to this later, but if I'm trying to understand exactly all of the validations that get applied for a particular type of RPC call I made, do I still need at some point to look in the Rust code, for instance, to see how all of that actually bakes out, like all the error messages I could get, that kind of thing? Or should I really be looking like from a GraphQL or from some combination of things?
I think for here, you probably were best off looking at the code for error messages, and looking into the validation. We haven't really made a lot of headway on standardizing error handling stuff at the moment, but it'll come, I'm sure. To disambiguate zomes and DNAs a little bit more. So this folder structure in the repo, there's this haps folder at the top level, and each one of these is a DNA in Holochain's terms. So each one is actually an entirely separate network, an entirely separate collaboration space, and they could have the same participants in all of them. They could have different participants. There might be, you might be involved in a dozen different observation DNAs and one agent DNA. You might be involved in one observation and 5 different planning spaces that are all coordinating. It's, again, with the modularization, it's up to people who are the end user to combine these in whichever ways they want. So at this first level is the network, and then within the network you've got this zomes folder, and you start to see the actual individual components, discrete blocks of functionality that make up each DNA. So in this case, I'm looking into the observation DNA, which is the piece of Holo-REA which manages the objective, quote unquote, view of reality. So all the subjective kind of measurements and observations of people come together and are stored in networks called observation. And you've got it broken up into different things. And I want to talk mostly as I go through this about the module architecture, which if you are comfortable with Node.js's module architecture, you're not going to find too many surprises with Rust. It's very similar. Some different file name conventions, but broadly it's just, there's folders, and those folders are modules, and you can import them into others, and it's all pretty straightforward and what you'd expect. So that's also kind of one of the very nice parts about organizing Holochain app code. And we've had some quite lengthy discussions on the Holochain forum, this one here, naming conventions, naming conventions and module patterns for Rust crates. And yeah, Paul Doust in particular and I had a bit of a talk through what works, and then we've gone away and implemented it. And this model that I have here now seems to be holding up really well for this complicated use case. And Holo-REA, to be clear, is kind of one of the few, if only, implementations or apps on Holochain that's trying to do things with multiple networks all coordinating at the moment. most people are building within one. And it brings out some things that make a lot of sense and have really helped to clean up this code and reduce the coupling between things as I've kind of moved through implementing them. So basically each zone, so at the moment, let's have a look at the process zone. So process is a good example to start with because it's got some links that are local to observation, and it's got some links that are remote and go and talk to planning in different network spaces. So it's a good one to look at. Basically, there's just a module naming convention. Rust calls them crates, but they're just bundles of code like anything else. And I'm breaking down each zone into these 5 pieces, basically. So the kind of most core one is actually the RPC crate. And this describes all of the JSON structures that are serializable into and out of each network. So this Rust layer now with Holochain, what you're coding in is you're kind of inside the backend. Like the Holochain backend is where you put your shared business rules that you want people to abide by. And it's conceptually a bit like being inside of the database storage engine. If you've ever used Elasticsearch before, the way that it does search indexing, and they have these things called percolators where you kind of define search criteria ahead of time, and as records get written, they automatically end up in those indexes. But even thinking about standard MySQL or Postgres or MS SQL, whatever you're used to using, you think about the internals of how that database engine works. It's not as if really, like an atomic operation in an SQL database is not, it's atomic in terms of your role as a consumer talking to the database. But inside the database, you write something into a table, it's got to go and write a bunch of bytes in different places to make all the indexes line up so that you can come and retrieve that data later. And the more work I do that iterates on Holochain, the more I'm discovering that that's kind of the logic that you're implementing as a Holochain app. So there's this kind of idea that the network is the database, again, similar to the whole blockchain thing, but there's the query API and the interface that you have with that network is up to you to define. It's not imposed by Holochain at all, and it can be very different depending on the purpose of the module. So if you look at like the deep key module that manages public and private keys for your identity in Holochain, that app has a very, it's not like a REST API, it's an API where you can feed it data and it signs it and spits out the signed data and stuff like that. So they can do whatever you want. And there's always going to be this RPC layer where you define a bunch of structures that define all the field attributes and that you can send in and out. And if you look at the GraphQL spec, you'll see all these fields repeated. This is really just coming straight from there, and a bunch of macros for Surge, which is Surge is the Rust JSON serializer, deserializer, and a bunch of stuff here to say, it's in camel case and don't output a bunch of null values and things. The other thing that you'll notice about these records is this maybe undefined type, and that is something that I'm surprised I had to write. I kind of thought that someone would have done it in Rust already, and they probably have, and I probably just didn't know what to search for. But that was to deal with when you're defining these structures for input and output. If you give them option types, when you're sending data into your Holochain network from JavaScript, you have to define nulls for everything that's there. If you omit fields, it gets complaints. So I went and created this special type that's goal is to not do that, so that you can kind of have the standard JavaScript pattern of, you leave a field blank and it stays at its current value in an update operation. You set it to null, it clears it. You change it, it changes the value. So that's what that's about. I haven't actually made it a crate yet. I'm kind of waiting to see if there might be something better out there that I can use. But that's one thing that these input-output structures have. And the other thing about this crate, is that it has not really many dependencies. Like the Holochain, JSON derive, and API ones are just a few structs, and they're mostly compile time. They're not actually runtime things. They won't add a lot of bloat. It's also important to have these separated out into their own module, because when you start doing communication between different DNAs, they have to speak to each other through these interfaces. And so they're going to need, so when the planning DNA, in the way that it's implemented at the moment, when you go into planning and start planning things in the future, it needs to link those to processes. So the observation DNA needs to run some updates as well. Yeah, when planning calls observation, it needs to know about all these types in order to be able to talk its language and speak to the input-output structures. So that's another reason to have them separately. And there's also actually some people that are building Rust front ends that want to be able to talk, so having these as a separate crate is good for them as well. Beyond that, the other stuff is a similar, I won't go into them in great detail. You've got defs, which are the Rust entry and link type definitions. These are separate because there are some cases where there's a bunch of patterns that are being evolved about mix-in zones. So if I look at this observation zone, say there's a resource specification zone in here, which just has a couple of definitions of stub entries that let you link into the knowledge layers in other networks. And you want these here in their own place because there are different other zones that talk to them. So you can't define them in the other zones because then you've got duplicates. They need to be in their own place. And so there's some separation there because actually the other zones that are dealing with them don't need to redefine the data types. This one does it. So that's defs. Storage and storage consts. Storage is sort of the internal structures that deal with the actual storage of these bits of data inside Holochain. Again, they're mostly dealt with through the JSON macros that Holochain and CERD provide. But I also just kind of wanted to show, so there's some basic framework stuff here that we'll go into in depth in a minute. But simple type conversions where you've got these external representations to say this is the data that creates a new entry. That needs to turn into something that actually gets stored. So there's conversions there. And you've got the same for updates where there's particular interfaces to implement where you take some payload and you can use the update an object in storage. And those simple kind of bindings let you do a lot of different things that in different ways that we might need to do in terms of generating state. And then lib is kind of the main one. And this is where all the actual logic for manipulating all these entries inside the Holochain DHT is done. So you've got a whole bunch of stuff here that basically these are the top level methods that when the zome gets called, so someone externally asks for create a process, they pass in this create request and the lib is using it here. And to zoom out and make all this a bit more relevant, the reason it's done, that's split out into that level of fidelity is that there are going to be cases where people are actually going to want to not just be doing builds in the UI outside of this, they're going to want to come down and have custom business rules and things that have domain-specific logic that speak REA and talk to other REA networks. And so in the example directory, there's a couple of stubbed out examples to show how some of that might work. There's two here because there are really two customizations to REA, which are the standard customizations that 95–98% of use cases, it's all you're going to need to customize. One is the knowledge system. So we have this DNA called specification, and the specification DNA, to go back to the Voyager here, it has these record types here. So you've got resource specifications, process specifications, and units. And these are kind of effectively the type layer that tells the system what types of things are. So the resource specifications might be things like tomatoes and avocados in one network, but in another network it might be organic tomatoes and nitrogen-free tomatoes and vine-ripened tomatoes. So it's up to every network of people in their economic coordination and what's relevant in their network as to what types of things they allow to move through their network. And so at the moment, these are just simple services where you can post definitions in and manage them. And I would say in initial versions, a lot of people might even hard code those, or they might have it just as a network that only one or two people as admins have permission to manage so that they can govern it more easily to begin with. But I think down the track, these things are going to need to be have collective governance structures put in place for them. You might need protocol councils, is the term I'm using, for people to decide what the resource specifications and process specifications within a network are going to be. And I use the term protocol councils quite intentionally because these things here, where you're defining the types of resources and the types of processes that can happen and be moved within an REA network, that is you as a group deciding effectively what is allowable and what's not, and what languages you can speak within the network. And so it's exercising a power over the people in that space and how they can collaborate. And it's also about building community. And so it's a lot of these discussions, when the rubber starts to hit the road and we get more communities who might be neighboring each other using them, are going to be about how we marry up these differences. And so you might have a network of farmers in one location that are using one set of resource specifications, and you might have a distribution network that's using a different set. So there's going to be a need for governance in both those places, where people have to come together and say, okay, how can I deal with, you've got these ways of talking about organic that provide more detail than what I can tell you. So what can I sell in your area, and how can I sell it? And how does that meet the expectations of your consumers? And all these are going to be questions for people as they start doing stuff with REA. And so outside of just being able to define those types, some of the first things that you might be wanting to do are actually defining ways that you think about those types. And so the folder name here is Beef Resource Specification, because there was a cold supply chain case study we were working with. But it could be anything. And this is a place where, so you can see here, I'm importing the standard REA, Holo-REA modules that deal with the resource specifications that REA networks understand natively. And so that, you get an ID and a name, an image, a note, and you get to decide how to measure it by default. And that's more or less it. And all the logic that we might want to build on top of that. And in this case, it would be things like, rather than creating a resource specification, you might pass in a different set of parameters where you're creating some definition of a type of cattle or a cut of meat, where you put in all these particulars, and it transparently creates you a definition of that, but also creates the underlying REA resource specification that's compatible with all of the tooling that might want to speak REA, and then links the two effectively. So you'd end up doing this kind of like, put a Holochain entry that describes your custom stuff, put a Holochain entry that describes the REA stuff, link them together, and treat them as the same within your network. And then you'd build business intelligence off that to be able to do things like finding all of the meat that's going out this week that has been harvested from an O-negative blood type because there's been a health scare, say. So this is probably the most common type of customization you would be doing. The other type is custom resource attributes. And so that's for cases where you're not talking about types of things, but you're talking about individual things. And there might be some particular metadata that you want to track with every resource, or with one type of resource in the supply chain. And so again, you'd need to be creating custom structs and schemas and storage that you're extending with non-standard fields, and then dealing with the REA stuff internally. And something else to sort of note about this is just an artifact of the composable nature of all of this. So here we're bringing in the Rust crates themselves, and we're doing this level of customization because we want to make some changes inside the DNA or the zone. But there's some other zomes, excuse me, there's some other zomes in this DNA which are not customized at all. So this process one here, it's actually just pulling the build of the standard process that comes out of observation process here. So I'm still waiting on advice from Holochain on how we link these to stuff that's been published, and setting up a proper publish workflow for all of this. But it should be this simple to be able to go, okay, I want a DNA and it's got these 5-bit sets of functionality within it. I can use these ones unaltered, which, because of the nature of Holochain and the way that network IDs are derived from the hash of the code, means that you can actually prove that you're using stock standard process functionality here. And so you can compose things without customizing in bits and pieces as you need to. So it's all, again, very modular and extensible. And what else haven't we talked about? In the specifics of Holo-REA itself, I've just at the moment tried to expose the minimum amount of functionality that's required. And so for most things, that means that when you look in the lib folder, you'll see that the receive functions are public, and the rest of them down here are all private because they're all kind of the internal logic of how the entries and links are manipulated in response to those external events. And because this is built into a spec, you kind of don't want people tweaking and fiddling with those things, or you want to make it difficult for them at least. So the idea is just to expose just a black box of what REA does, so that you don't have to really think about it too much and understand it in depth. You can just log events and know that it's all happening for you as it should. And yeah, I did want to say some things about the modular nature, just on reflection of some of the stuff we've walked through lately. Ontological translations I'll leave for a sec. But we've done some stuff just looking at cross-border trade and some of the complex regulatory things that are involved there, particularly with China and the Great Firewall and all that stuff. And so you can't actually see it in this branch because it's still being worked on. Although if you see, I've got a proposal stub here with a bit of compiled things because I've had that branch checked out. So proposal is one of the DNAs that's still in progress, that's sort of needed for minimum viable product in terms of coordination. It's pretty close to ready. But anyway, we sort of discovered that all of these regulatory constraints are essentially about information visibility. And because you have this facility to break the network apart into different observation, planning, proposal, or let's just say those three because they're the key ones here. Because you have the ability to break it apart into those spaces, you can do stuff like you can have a shared proposal space that allows people in the supply chain, all the way from someone who's selling beef in one country or selling vegetables in one country, or building a wind turbine, whatever they might be doing, and someone on the other side who wants to import it, they can have a shared network space where they can do all the agreements to figure out, how do we, the proposal is I want to get this from A to B, and all the stuff in the middle might be figured out as part of that proposal. It might be federated off into, one side of the border might deal with their own stuff internally in a separate proposal space and not share their data with this side of the border. But you can kind of link it back as you need to. And you can also have that proposal space spreading over multiple observation and planning spaces. So it means that all of the internal logistics as to how things were moved around and ferried from A to B within one country don't have to be exposed to the other country. And you can also, with the nature of the way Holochain networks work, you can kind of just take a device that's had permission to be in some parts of the network and pull data, and you can give it permission to end up in another place, plug it across, and all the data replicates automatically. So for customs officials at the border, just being able to go click, click, and the data's there is a really powerful thing, and something that fits well with the way things are done today, without trying to, take over the whole world and change all of the ways we do things. Given that that use case works, I'm pretty confident now that easier things and less crazy use cases and more grassroots stuff is easily possible. Like, sort of, the Chinese government is kind of one of your ultimate test cases there. I think if they're happy with the data ownership rights and things, then everyone else is pretty easy. I think that's most of what I wanted to talk about for Holo-REA itself. And we've only just started really to touch on the internal guts of it. We're kind of coming up to an hour and a quarter now, so I might just pause for questions here if people have got more questions on using the framework itself and developing with it before we go into internal bits and pieces. And we might even have to postpone a lot of this stuff or skim over some of it because there's a lot of things we could talk about. I don't want to leave enough time for questions.
Hello, can you hear?
Yuri.
Yes. Can you hear? This last one, you skipped this sort of. I'm very much interested in these ontological translations at the boundaries.
Okay.
Because I think that I'm very interested in what's happening there.
Sure.
Because I think that's the key. But anyhow, yeah.
Yeah,
Really,
it is. It's an interesting thing of when you have this fractal composable nature of network space and everyone's sovereign of themselves, it's a difficult technical challenge to allow for diversity of language and expression within each neighborhood, but let them all talk to each other en masse and share data. So at the moment, that module is still coming, and it would be nice to see it on Holochain. I think I've said it before that Holochain is really a semantic web project when it comes right down to it, and having some well-vetted functionality in Holochain to manage ontology would be really cool. Just to break through the jargon for those that haven't heard the word before, ontologies are really just about systems of meaning, particularly language systems of meaning. So back to the browser here. If you kind of think of these economic coordination spaces in terms of, as Art likes to talk about, carrier and signal grammars a fair bit. And so if you think about REA as being the signal grammar, the carrier grammar within all these networks, because if you're going to use Holo-REA, you're buying into the idea that you want to speak REA as a language to describe how you're moving resources around. And so that's the carrier that everyone's connected by because they're all speaking REA. But then the signal that makes each network different are these things, the specifications and the units. It's how do you classify things and how do you describe things. I did actually do a bit of a diagram. Oh no, it's an older one. This one. It kind of becomes a case, like at the moment, because it's not typically a priority, which is unfortunate. Ontology is sort of the thing that when you don't do it right at the start, you get ontological leakage and it makes more of a mess over time because you never got a handle on the meaning to begin with. But it's also sort of a reality that until you start connecting systems together, people don't care so much. But what would happen eventually is this sort of thing. So when a data payload comes into one network and you've got a particular set of classifications, this is an older terminology, but classifications or specifications for these purposes call them the same. So a particular set of types for a record, you then basically need to have some functionality within this network, which, speaking about protocol councils and things, this is what you would create out of those discussions and agreements between people. This is the actual technical piece of what it comes down to. How do you translate the ontologies of network A into network B? And back to the whole vegetables example, how do you translate, in this one, maybe this is tomatoes and there's tomatoes over here, so we can go straight to there, but there's no capsicum, so we have to go to like chilies and mild chilies or something. So you'd have to perform these translations, take a different structure for the record that actually has different data before you replicate it and spread it out. And the bridging stuff that lets agents bind Holochain networks to each other is kind of not yet at a point where it's flexible enough to be able to do this as readily as I would like, but it is planned. It's mainly that at the moment those connections are quite deliberate and kind of one-to-one. Like I can connect one observation network to one planning network and maybe one other observation network, but really what I want to be able to do is connect one observation network to as many other observation networks as I want. And I want between all of them to be able to specify, okay, when I get some data into this network, because of all these translations, I need to actually send this different record to the other network. And all this stuff obviously is going to bubble all the way up to the interface, because when you're there interacting with some community, you're going to have something on the screen that says, when you're sending this event, do you want to replicate it out to these other networks that you're a member of? And do you want visibility settings and all that stuff? So yeah, that's what the ontology translation ends up looking like. And if people have more, there's potentially ways with automatic reasoners and limited forms of AI that kind of stuff could be done more automatically, but I'm sort of also of the opinion that it should be fairly human manual process, at least initially, because you want a lot of awareness and thought put into that stuff. And if it's done automatically, it might just end up with things happening that people don't agree with and unknowingly, which would not be great. Yeah, so that's, do we want to ask anything else about that? Does that satisfy your question, Yuri? Cool, we'll say yes. So I'll dive in.
Yeah.
Yeah, cool. I'll dive in a little bit into the back end. And in case we don't quite get through it all, I guess I'd preface this by saying that this was just really an iterative process. When I started this, I just, tried to do the most naive, simple thing I could do to store stuff in Holochain, and did that in a few places and found the bits that were common and made some abstractions to get rid of the duplication. And I've just been doing that process iteratively, really. That's all it's been. But because of the nature of the ValueFlows specification in the protocol, and which you can kind of get a sense of, like, this diagram doesn't get laid out well in the way that it does it, but the number of connections here is very clear that this is a highly linked data set where lots of records point to other records. And so really what I needed was for Holochain to be a graph database. And that's what this module, in the lib folder, there's all these ones that start REA are all of the Holo-REA ValueFlows protocol stuff. So that's mostly record type definitions and things. But this HDK graph helpers is a library that I've just been adding to through that process of iteration since the start, really. And there's a bit of a README here, which is worth kind of diving through quickly. Although I'll just do it like this. Basically, the short thing to say is that I haven't really spoken much about Holochain's underlying storage primitives yet. So this is the stuff that happens inside Holochain as the database when you're coding. And it basically gives you these two things. It gives you entries and links. And the two underlying storage structures that those map to, for those who know what these terms mean, the entries are a content addressable store, which is basically a kind of storage that anytime you put something in it, you just take a hash of the thing, and that's the ID that it has, which means that if you write the same thing to the database twice, it'll be stored under the same key, and essentially it's an idempotent operation. It doesn't care if you write it 10 times, it's still going to be there. So there's some features of that make it quite useful in distributed systems, and particularly in distributed systems like Holochain, where we're completely foregoing consistency and saying that we don't really need it and it's all eventually consistent. Being able to basically know that if you know the hash of something, you know that it's stored is very advantageous a lot of the time. And the other thing is links. And this is they call it an entity attribute value store, which is a primitive that basically lets you assign key values to things. Like the entity is, say, an event, and the attribute is it affected this resource, and then the value is the resource that it affected, sort of thing. And that EAV primitive is something that most document databases and graph databases and things are all built on under the hood. And so these two things, simple as they are, can actually give you the pieces that you need to build more or less any storage data structure. And the other nuance there is that they can be private or public. So it's defined based on the type of entry, and sometimes some types of things get shared with the network, other types of things are just local to your chain. So you can do public and private data and have stuff that only you can see and selectively release to people. So those are the pieces that you start working with. And from there, it's just kind of building up, again, just based on common abstractions, things that I've needed to make all these pieces hang together. A core part of it in this implementation has been basically updates, because there's this issue with a content addressable store that whenever you update something, the hash changes. So the ID keeps changing, and it makes it hard to figure out what the history of things was and whether what you're looking at now is the same as something you were looking at before. And so what we ended up doing, we created this concept called a key index. And if you look at my entry type definitions for things, so let's use process as an example again. If you look at the definitions for process, you can see that there's this process entry type which stores the actual data for the process. Then I have this base that links to it. And when you go into the HDK graph helpers and look into might be entry helpers somewhere, I've refactored this thing a few times, so it kind of moves. Or it might even be in record helpers. Create record, here we go, yeah. So when you create things with this framework, you need to know the base entry type, the entry type, there's a link type between the two, and the payload you create it with, And essentially what it'll do is we'll go and create the entry, and then this base address gets saved as one of these base entries. Actually, there's a diagram for this too. Oops. So looking at these here, you end up with this kind of structure where there's this base entry where you're actually taking the initial hash of the record and saving it, and you use that as an ID to link everything from there on. You don't ever use the actual record because that keeps changing the hash. And so there's some interesting things there because it kind of breaks the idea of addressable data in distributed systems. And so in retrospect, I'm not the hugest fan of it. And I think there's potentially, but there were other reasons for doing it as well, namely that if another network is linking to an entry and its ID changes, then this network has no idea how many entries have been linked to. It can't tell whether those two different IDs were for the same entry or not. So between networks, it becomes awkward, and there's not enough helper stuff in Holochain yet to make that easy. Effectively creates this base address, and that gets used hereafter, and all these other helpers are really just to deal with that base address and that level of indirection. There's some other types. There's anchors where you actually want to have things with a primary key, and it's sort of similar, except that you write that first link yourself and give it an exact name. And so when you look at the unit API, say, which is in specification, the units are all stored by their IDs rather than the address of them, because the ID is actually the symbol of the unit. And when you actually look at the code, it's really just a different helper that you're using of creating an anchored record instead of receive, create, instead of creating a record. That's the only difference, because it all just gets wrapped up from this abstraction. What it does mean is that you are, as an app developer, perpetually needing to reason about whether your links are pointing to the same network or a remote network, because the helpers are different. So again, looking at process as an example, although I look at the process lib here, I've got here two sets of helpers I'm pulling in. I've got query direct index with foreign key, and I've got query direct remote index with foreign key. Oops. And I just killed it, didn't I? Process. Yeah. And when you look at it loading up the fields here, you'll see that basically these ones here linking to events are in the same network, the same DNA, so they're using these helpers that are all managed without this extra bit of indirection that links another base link off to another network. And then the ones that point to remote networks have a different helper that wants to know, basically we're telling it to fetch it in a different way in terms of how you call through the DHT and manage all these links. And it kind of mirrors a bit the entry and link type definitions that you do in the zomes. And these two things together in the current state of affairs, they're where most of your user error comes in as you're developing, just mixing up these functions. So maybe jumping a bit ahead into kind of future steps and things. But there's potentially some work that can be done to make that process less error prone. And I also point out these stub zones for remote indexes. So looking at the observation zone, say, so you've got talking about these type things again. In the resource specification zone, there's nothing in here that lets you find all the resources that fit a specification. That actually happens over an observation. And you have this zone for resource specification that just defines these base types that point into the other network. And what that means is that then when the economic event and resource zones are doing their thing, they can link to these entries and it all works. And I find the way that these crates have been organized makes that quite nice as well, because the fact of you pulling in and referring to the storage constants from other modules that aren't yours just makes it very clear to look at the header of the file and know that, okay, you know, this resource specification here, it's going to link to economic resources because it's pulling in that constant to tell it where to link to, basically. So yeah, being able to very clearly see how things are interrelated from the import graph is something that's kind of naturally emerged from this module architecture, which I'm pretty pleased about. So, yeah, excuse me, just gonna have some water. There's a couple of other patterns here. Oops, that are sort of interesting that I'd just like to show. So these links that I'm showing at the moment are direct links where you know, you look at the resource specification. Actually, if I look at the spec, is probably the resource specification here. There's a query edge to find all the conforming resources that conform to each specification. Excuse me. So it's a direct link between resource specification and economic resource there. So it's fairly simple. But you look at other ones. I'm going to use a better file. That one's silly. You look at other ones, for example. Well, actually, just looking at planning is where they are. So we talked about these future things from event, commitment, and intent. And there's these records in between that join them all called fulfillment and satisfaction. So the relationship is that commitments and, events can fulfill commitments. So basically it's like you've done some real things to fulfill an obligation that you had. And satisfactions and commitments can both, events and commitments can both satisfy intents. So these plans for things to happen, people can either commit to making the plans happen, or things can happen that go towards making them happen. But the point to note about these records is that these are kind of joining records that are a bit like compound keys in a traditional database system. So this fulfillment's purpose really is to link an economic event to a commitment. And the other stuff there is really just metadata about how that link looks. In these cases, it's the quantities of how much was fulfilled, so that you can have that relationship to say that, you know, oh, you wanted 10 of these, I've got 5, I'll give you the other 5 tomorrow. So what it ends up looking like in code is that you get a very slightly different module structure where you end up with a couple of different lib folders. So while process just has the one lib because it's only got one set of logic within one context, if I look at fulfillment, it's got lib destination and lib origin as 2 separate pieces. And what happens essentially is that in the planning zone, when I look at fulfillment here, it's got these methods where it'll people can create fulfillments, read them, update them, delete them, standard CRUD stuff. But if I go and I look at fulfillment in the observation space, what I see is actually that these things are in the past tense. I've got things that trigger once a fulfillment has been created somewhere else and updated and deleted. And at the moment, they're just running through the zone-to-zone call API, but they should eventually, once the specs standardized a bit more, be using the Holochain signaling API to basically just broadcast that a fulfillment was created, and then everything that needs to know about that could update its own indexes internally. And it might be worth showing actually, just the similarity of these things. As you start to pull stuff apart and look at it through different comparisons, it becomes very clear where the shared logic is. And this is some stuff that I haven't really wrapped up a heap yet. But just looking at the differences between these 2 files, like it's mostly the constants that are pulled in. You can see, so this destination one here is what's in the observation DNA. This origin one is what's in the planning DNA. So you can sort of see straight from looking at the top of the file that in the observation DNA, the fulfillments are dealing with the indexes on events, and in the planning DNA, they're dealing with the indexes on commitments. So it's these 2 sides of the index, one in each network. You can see basically the key differences are here. So there's some more code there that's commented out, but in the planning space here, it goes and it actually runs HTTP call and it sends some data over the wire, over the RPC gateway into the observation DNA, which is where it's calling this fulfillment created, which will then go and actually trigger all this action to happen inside observation. So that's how I'm doing compound indexes that are synced over 2 different networks. And of all the different types of indexes in there at the moment, those are probably the most complicated ones that are implemented. What else? Yeah, it reduces. I wouldn't recommend it, mainly because if you've done JavaScript, you're getting a lot of stuff for free that you don't realize how for free you're getting it. But I also want to say that what's been done here. So when I talked about the spec in the beginning in terms of how resources are sort of derived from events, you never edit a resource directly. It's kind of not exactly true because you can update it with some finer details like note and stuff that aren't really accounting things. But it's actually in the creation of events here, when you create an event, that you may optionally create a new resource in the inventory in response to the event. And after that, you've got an ID you can refer by. Yeah, I just kind of wanted to show this because when you look at the event lib, which is where all the logic about all this happens, and you can see there's quite a lot of logic in here because it does all the quantities and things that happen when resources are changed. Or is it here? Maybe it's in storage. No, or is it in resource storage? Don't know my own dependency graph. Yeah, here we go. What am I talking about? Yeah, so through this API, I'm basically using this updatable that's part of the HDK graph helpers that gives you this discrete little way of defining how things can be changed. And I've got this update request payload, which is actually coming from an event. I think it might not be here. But the update request is both an event and a resource. So it's a few different things. Update request here is just the metadata about the resource. Sorry, not the accounting stuff. These are the ones that are interesting. So I can update a resource in response to an event creation request. And that's actually all you need to define is that one step in the application code. If you look in the record helpers in the helper code, the update record stuff, here it is. This update entry is kind of where it comes in, and this is running this update with out of that trait, all those things. So basically this is the calling piece of code that every time you run an update goes and executes. Did I lose it again? I did. It goes and executes that bit of update logic to describe how the transition's made. And I've done it deliberately that way at the moment because it fits both best with the pattern that Holochain likes to use, which is kind of you make all your changes immediately and you throw an error eagerly so that basically you can rely on consistency in the things before. But there might be a requirement at some point where I need to be able to pull the version of a resource that existed way back at some older point in time. I can write a different bit of calling code to do that without having to change the update logic, and it can just run it across multiple events all at once to create the resource. And there's been some discussion recently about whether we would want to even store resources in Holo-REA at all, or just derive them from event and a log of events each time, which is how some older implementations have done it. And there's sort of pros and cons to that. Like it's a nice way to do it in a distributed system because you don't have to worry about conflicts, but it's a scary way to do it in a distributed system because you don't have to worry about conflicts. Meaning if it's just an event log and you put in 5 different events and they're all out of order, it doesn't really matter, it'll figure out the answer. But maybe there was a state in there where you were exceeding a balance that was part of your budget or something that you want to actually have the system go, hey, there was a conflict here, these 2 things kind of occurred. And so the fact that I'm storing a resource at every stage at the moment means that probably is how it would be handled. And dealing with the conflict, I think, is better for the moment. But yeah, that kind of brings me to transactionality and consistency guarantees with Holochain apps. And looking in economic event at the creation logic, which is also update logic for resources, you start to get a bit of a sense of this because, so here we go, this is the public API within Rust for what happens when you receive a new economic event creation. And so you can see here that basically it'll start, and if you want to make a new resource, it does that. But if there's some inventory fields there that are specified, then it's going to update the resources as well. And then you go to create the event, and then you do all this anchor index and stuff so that you can do all the queries later. Now, what's problematic with this is that these look like methods that are going to be fine, but actually these are dependent on the validation callbacks for those types. So if I look at the economic resource storage logic and I look at this bit here, which is, where's the validate? Here. So here's the validate function for this entry. So there's ways that a resource can fail internally to be created if the parameters aren't right, and you won't actually know that until you get to creating a resource. So it's the same with event as well, by the way. So there's ways that event, might fail validation. And at the moment I can work around this because I can basically create the things and down here do the indexing and creating anchors after they've been created, which basically means that if this does fail and I've already written some junk resource that's now orphaned into the system, it actually doesn't matter because I haven't created any links, so I can't actually retrieve it from anywhere. And that's an okay workaround for now. I know that there are plans in Holochain core to introduce essentially, it seems like it's going to be a declarative framework to describe data dependencies. I'm in some conversations about how deep that needs to go. I don't think it really needs to check about old data. It can kind of just be, if you can treat everything that happens within a request as one transaction, you're in a much better place. And I think there should be some ways that that's doable. But yeah, for now, the whole, these question marks here are, there are some, what's the word I'm looking for? Some convenient syntax in Rust that basically if this function throws an error, it will just abort the whole function and return that error here. So that's a good way to kind of make sure everything's succeeding before you keep going through. And it is actually so far enough for this implementation. It doesn't need to be any more robust than this, but I would like to not be creating junk records and if things go wrong later on. And there are some validation requirements that are quite complicated and involve things between networks that we might have to sort out later, but for now it's not too bad. And we've talked about complex indexes. Oh yeah, I also just kind of wanted to point out this new type pattern for addresses because basically I've just set up an alias that does a few things here. Again, I was very new to Rust when I wrote this, and there's probably crates straight out of crates.io that are useful for this. But the goal here was basically to have compile time type wrappers that would prevent you from mixing up fields. So these should have 0 running costs. I need someone who knows Rust really well to check this. That'd be really great, actually. That's a code review I need. And it's sort of been fiddly dealing with those types of times, but the benefits are really worth it because it lets me go this entry for an event. The provider is an agent, and if I try and assign that to a process, it'll actually throw me a compile time error because they're two different things. And translating to the underlying hash is reasonably easy, but I'm not quite sure if I'm doing it in the idiomatic way yet. And yeah, I'll leave it there in terms of the really deep bits of this. Maybe if there's people got other questions about database mechanics and graph architectures and things before we get into some like future desires and stuff.
Hi, thanks very much, Bosby. Hi, I'm just asking about, a couple of weeks ago, I dived into your Gitter channel, and there was, I think somebody from the Netherlands or Austria maybe, looking at doing RDF translations to the GraphQL interface.
Yeah. Is this,
and I think that's, yeah.
This ValueFlows Gitter, this one?
Yeah, that's right. Yeah. So I was curious. I come from, I have some RDF experience and I'm familiar with that side. So I just was wondering if anything came of that you know about, or whether that would be useful. This is pretty dense stuff, and in some ways, an RDF you know, like a turtle syntax, or you know, all the interoperability that comes from JSON LD. You know, what your kind of take is on that, and whether that would be a useful thing if it's not in there so far. Because I can look at turtle and just kind of grok it quickly.
Yeah, sure. It's interesting. It's all sort of, you know,
GraphQL seems like a tree structure. You know, it's a way of spawning trees or attaching trees, which is you know, important and very, very useful for actually building stuff. And this is, you know, a fine piece of work based on that. But I'm just, you know, when it comes to the sort of modeling side, and, you know, kind of iterating around what it is you're trying to do with your economic network, then, you know, what might be the best ways of doing that. That's kind of where I see perhaps the value of working in RDF initially. Possibly a bit of ontology checking, not runtime, not operational, but model checking, if you like, and kind of thrashing those definitions out before you commit to spinning out some GraphQL, or, you know, that.
Yeah, it's all the things you've said are exactly the right places to be looking. So you found your way through. That's a good nod to the fact that all the documentation kind of works. But this all VF total file inside the ValueFlows repository. So within that, there's a release doc in progress folder.
Okay.
And you'll find a turtle version, JSON LD. There's just the XML based RDF as well. But I think I know the person. Their name's not Almeida or something, is it? I think I know the person you're talking about. And I have seen them. Yeah, there's this one here, Protege or VF, which I think is someone.
It's just the starting point, really.
Yeah, it's kind of been done by hand, the RDF and ValueFlows, and so you do get the occasional weirdness with it. And there has been one person in particular recently came in and started cleaning stuff up and doing Protege modeling, which makes a lot of those little, you know, it'll just be like the wrong letter somewhere or something because it was done by hand. So they're all mostly figured out now. And I would also encourage you, if you want to like look at subsections of this and understand the pieces that are outside of ValueFlows, because the issue with the RDF grammar is that, you know, it's RDF and it's semantic linked web. So there's stuff here, like all these imports that you don't, you know, you got to dig around the internet to find out what those terms are. And like OM is the measurement ontology we use. There's some time stuff, some geospatial mapping. All of those things are in here because in the nature of GraphQL, it's not like semantic web, all these schemas can work together. It's one schema per system. So the schema kind of has to describe ValueFlows as well as all the things around.
Right, yeah.
And the GraphQL...
the identifiers aren't, yeah.
Yeah, and all these aren't great ones. All these comments and stuff in the GraphQL are actually just taken straight from the stuff that's in the RDF. So, and all the field names match and stuff. So there's parity there, or at least there should be. But also with the GraphQL, like I generate this schema when I build, which is the whole thing. But I also generate a JSON schema version of the entire spec. And just, I'm not entirely sure how the JSON LD version in here is generated. So this one might be more accurate given that it comes straight from the spec rather than potentially being manually created, but I don't think it is. I mean, we've got another 10 minutes until we're coming up on the 2 hours. So maybe I might just open it up to questions in general and leave this up on the screen so people can look at some of the other things that I would have talked about. Because a lot of this is really aspirational and goals that I would like to see implemented just based on my own pain points developing. And at least, so we've talked about duplication of link macros and disambiguating what's local and remote, and the type tests. And those are the big things that kind of come as gotchas. But the bigger work, I think, is mostly about where is it? Standardized common zome traits. This forum thread is very much worth a look, because there's a bit of a list from the Holochain apps team in here, this one, and I've added a few more here, that people trying to think through what the commonly reusable app functionality might be that we want to release Rust crates for, so that you can just drop it into your apps. And there's some stuff there that seems like it's dependent on other things and quite core, like REST standardization is one thing. Like I've seen people talking about Holochain URI resolvers, but you kind of have a URI resolver with a REST API. It doesn't work if it's just arbitrary methods through JSON RPC. So having standardization of those patterns so that we've got coherent REST APIs, so that we can have zomes that know how to check that things exist in other networks to do referential integrity checks and stuff. All these little pieces of things that I'd really like to see more community energy being put into developing as shared. My experience is the best way to do it is to just kind of make it the community's problem, really. Like if you've got a thing you want to do, like I want to start thinking about timestamping. So I just started a forum thread about building mixin zones for entry timestamping and started a discussion about some of the ways we might do it, because actually timestamping in a distributed system gets to be quite a complicated thing, and there's many different ways you could do it depending on the trust model in the network. So it makes sense that we don't all want to be writing a thing that does quorum time, and that's fairly common functionality. So yeah, that kind of stuff. I think there's a lot that can be done there just to make the app development experience easier. But the bigger one, this one, having like a compile time meta framework. And what I mean by that is this work that I've been doing to pull these things out and abstract them away into functions as much as I can. With Rust, that'll take you up to a point. But then, look at all my storage code where I'm like exhaustively declaring this, and I'm exhaustively declaring this, and it's very verbose. And macros are what you'd want to reach for, like right at the end, to be able to do these things in a way where you're not having to declare the same field 5 times. You can just go, this field is this type, and have it generate it for you. And I think a framework that's like a compile time thing that's all macros that lets you declaratively design networks of networks rather than just individual networks, whereas all the tooling now is kind of for within one DNA. But what does it look like to describe a whole network comprised of multiple DNAs and how they connect? And how much of this boilerplate can I get rid of in doing that is sort of the big open question for me in terms of making it error-proof, for want of a better word. I don't know if error-proof is ever a thing, but as close to error-proof as possible. Yeah, let's leave it at that. I might just open up for questions if people want to throw things at random. We can just go until people want to drop off. Really, I'm happy to keep talking.
Can I just ask, possibly? And thanks a lot for going through all that. It's a massive amount of work, and I'm grateful for you digging all into that. How are there things you're waiting on that are really holding implementations back in the core? And what are your feelings on functional applications and timelines and all that? Does it feel like it's hinging on things, or does it feel fairly straightforward?
It's a bit of a mix. Hang on, let me. I should have probably shared screen again. There's not much that feels like it's really blocking me. And the stuff that I'm kind of still needing to scope out, I've tried to log, so I've got a pretty decent list of it. It's like, the capability stuff I think is all going to work pretty well. The timestamping, that's one thing that again, shared module kind of thing. Countersigning is not something that I've talked about yet. It's not actually something I've implemented yet. I know other people have, and I've seen code of how it's done. I think it was it's essentially about you know, you've got to pull some stuff from the source chain of the record and then hash it and store it into your source chain, and that basically means that you've witnessed it. It's pretty simple to do, I think. I think it's like an entry chain header and where is it? Oops. Anyway, I'm sure there's others on the call that know these pieces better than I do. But yeah, there'll be pieces in here somewhere that here you go. So there's timestamp, link. I think it's a provenance actually, where you might start seeing signatures and sources and stuff. So those let you do the witnessing things pretty easily, I think. And you know, I think the ideal mix-in zone for that is just an API that sits there that lets you pass a hash of something and tells you and sign it, and that's all it needs to be. Probably the big one is groups, I think, group agents. And because of sort of the ideological underpinnings of Holochain, that you know, it's all about agent centrism and individual agency and user sovereignty. So, and it's kind of welcome, I think, that there's no native way for a group to have any kind of sovereignty or identity, you know, because they're not real people as much as corporations would love to be real people. So it has to be an abstraction if you want to create a group. And I think we're kind of, there's something in the forum about that as well. How will we handle group agents? And it's kind of becoming clear, and there's a parallel, like when you're a single agent, you join a DNA, join a network, I should say, and when you join a network, you've got this validate agent callback that lets the network decide whether you're allowed to join or not. And you can do other stuff there to register yourself. And it'd be a similar thing for a group agent. You just have to create a DNA that's a self-contained network that manages all the data about who's part of the organization and how permissions work. And then, you know, you connect that with a network that knows how to talk groups. So there's some trait there that's the communication protocol. And it'd be a similar thing. Like then the network goes, okay, am I allowing groups? Am I allowing this group? Let them in. There's registration. They're part of it. So I think that architecture kind of mostly makes sense. But the thing that will hit reasonably soon, I've got kind of a milestone for the whole thing because there's a lot of pieces. But I'm calling optimal flexibility. Where bridges can be made in one-to-many or many-to-many configurations. I think the REST stuff is part of that. I think URI resolver logic is part of that, because once I can connect multiple observation networks to a planning space, I need to have something in a record ID that tells me which network to go to fetch it. So that's kind of, I think that's work that's, you know, it's so core that it should really be a community effort. And yeah, once that's done, there's more signaling stuff that can be done, and I think that makes most of this work in the way it needs to. And you can even do cool stuff. I haven't done it yet, but there's a fairly standard interface in GraphQL, this thing here, publish, subscribe, unsubscribe, that you can implement that lets you do real-time updates from GraphQL. So that's not a lot of work to make that work in Holo-REA, and then we can have totally real-time economic apps where everyone sees everything going on, which should be really cool. Yeah, I don't know. There's not a heap else that I'm really feeling and that is missing. I think it's just, you know, I'll probably figure out I need more modules as I go, and then we'll start to know which where the gaps are. What about you? Have you got particular features that you're chasing?
A little bit early to tell, actually. I mean, we've done a very high level kind of idea of what we want to do with food and buyers clubs and all that. There are going to be some of the group agent things you were describing, I think, will be needed because we're working with associations that have a joint kind of inventory and stuff like that. So that'll be necessary. Other than that, I think most of what you've shown would cover. I mean, I can't think of many instances of what we need that would fall outside of what you've shown. But yeah, something will come up eventually, I'm sure.
I've got a a domain-specific one that would be quite useful in a lot of cases. I think there's nothing really in ValueFlows for doing like IoT stuff. Like, you know, you kind of want something that just lets you record a bunch of measurements against a resource and you know, this was again the cold chain stuff, so it was about temperature. Yeah, I think it's just worth pointing at this one because, as with all this stuff, like if you're trying to build a system that you want a lot of people to adopt, the best thing you can do is find a standard where someone's already tried to create a thing that a lot of people will adopt. And in this case, it was someone in one of the ValueFlows threads found this semantic sensor ontology. So there's already a domain out there where someone's gone and, you know, described all the ways that sensors should be able to record data and how to record information about the sensors and the things they're measuring and stuff. So yeah, this seems a likely candidate for some of our use cases to just build a module that's compatible with Holo-REA that can talk to the observation module and let you just do arbitrary measurements against events. But yeah, it's a cool one because it's another protocol to bring together.
Can I just ask I was speaking to Tom in Lisbon about the beef ledger thing, and would you be able to speak to where that's at and what's happening with that?
I don't know how much I'm allowed to speak about it, so I probably shouldn't. But that's been the cross-border kind of case study exploration thing. So it's I guess the thing that's been interesting with it is it's required depressingly little customization. You know, there's those two folders in the repository sitting there as stubs were going to be some customization for different resource attributes and type attributes and things, but to solve the basics, we haven't needed to do any customization, so they are sitting there as uncustomized, and it works fine. There's the other set of modules. I think I don't know if Siddharth has thought about them heaps yet or not, but so there's a bit of a relationship there where Sacred Capital are building a bunch of reputational libraries that will sit on top of this. And it's a pretty clear chain of responsibility, sort of like Holochain being the data layer at the bottom, REA being the quantitative measuring, you know, trying to be objective reality, and Sacred Capital trying to be the qualitative judgments that are made from that objective reality. And yeah, Siddharth and I have been talking, and it seems like there's maybe a set of modules that, whether he builds them as part of Sacred Capital's offerings or whether other people build them, that might be useful in other contexts, because, you know, not everything is an economic resource and not everything's an economic system, and there are other bits and pieces that reputation has bearings on. Do you have much of an idea in mind, Sid, about what componentry you're looking at building, or is it all emergent?
Thanks, Sam. I think our conversations over the last few weeks have been really helpful. So it looks like we're going to go ahead with some of the really basic reputation data types. And so there'll be simple libraries like likes and swipes and claps. And these are particularly data types that are virtual or non-material in nature, because I think Holo-REA has done a great job of, I think, capturing libraries of most material movement of resources or material resources. So yeah, that's how we're gonna, you know, go out and start publishing some of these libraries, and then get to more complex stuff, which is computation of reputation scores, and then even staking of reputation reported across networks. So that's kind of like the plan for 2020. But yeah, really looking forward to collaborating more going forward.
Cool, thanks. I guess unless there's any final thoughts, maybe just looping back a bit on the start of this call, it might just be worth finishing with a few random thoughts on the power dynamics at play with this sort of system. You know, the goal of ValueFlows is to be as unopinionated as possible and to, you know, kind of allow space for infinite dimensionality in terms of what constitutes a resource and how it's measured and all that stuff. But there are, as we've talked about with these specification records and signal grammars and stuff, there's power dynamics at play and who decides what is measured to begin with and when you decide what's measured, you're actually deciding what matters and what people are going to optimize for. So there's huge implications into how it affects behavior. But there's also power dynamics in deciding how you record the measurements, and that's kind of the meta protocol. Like in this case, it's ValueFlows, but there's definitely other ways to record measurements. And more power dynamics in deciding how you store and access the measurements. So that's as much Holochain and agent centrism as it is the people in the networks and how networks talk to each other and who's in which collaboration spaces. But yeah, those kind of key principles, I guess. Measuring things changes behavior, and changing flows between systems changes the behavior and the properties of those subsystems too. And that's getting a bit abstract, but it comes down to things like you might create an economic network in an eco-village where you might want to reward people who spend time in the garden by giving them discounts or free food at the cooperative, say. And there's kind of like a linkage between gardening and the accounting that's done there and the co-op and the produce they use. But you could do that, and that might be really great for your community. But you might also find that the side effect is that the co-op actually had a bunch of stuff they needed to pay in real world dollars, and you then impoverish them, and the whole community falls apart. So there's a lot of careful design in play to be taken in how you deploy these systems and what the repercussions are. So much more to come on that, and much more case studies and accounts and things as to how these concerns unfold.
Right. Thanks for that. Actually, those thoughts are really important, because I get a sense that when on adoption of this work, it'll just take a life of its own. If it's out there scaling up, being adopted, it'll become de facto. And on the Planet project, actually, which was there's some principles that I put a little link in earlier. I'm a tech guy, so I was learning from folks who've got a lot more experience and background than I have in this. But there was definitely an attempt to try and separate trust from reputation, and also to put to the fore as have a sort of first-class citizenship of conflict resolution, and an idea of intention, I think, and trying to sort of build out, I don't know about protocols exactly, but almost like the grammar of conflict resolution as a first-class citizen, to try and, I suppose, help evolve from a human agency viewpoint these protocols. So I just want to thank you for putting that up there alongside the build, because the build, is going to be important. And it's going to take, as I say, it's going to influence people, organizations. And I'm very interested in what you're doing, Sid. I don't really know much about it, but this is where it really sort of, I guess, the rubber hits the road is the wrong metaphor. It's to do with people, so I don't like that. So something like that, where it counts.
Yeah, there's a whole can of worms for sure. I'll just point to this on the modules in the Holo-REA framework wiki page. If you probably search Google for that, you'd find it, I'd say. But there's a stub here on legal dispute resolution as being a component to make, which some people are interested in doing. And again, to the modular nature, like it's kind of interesting that in all the places where ValueFlows has been deployed in real situations, which Lokicon, LOCECON.org, and Micah Reiser website are probably good places to read about some of those. But they've never needed legal dispute resolution because they've all kind of been trusted environments where people got on, So, and if that stuff did happen, it was dealt with by humans outside of the technology stack. So, yeah, it's interesting thinking about some of the more corporate applications for this and the fact that people sue each other in corporate environments. So how do you provide facilities where they don't have to do that as much, and legal recourse when it goes wrong and all that kind of stuff, which is, yeah, difficult to design for when it's distributed systems that no one owns and controls and is probably liable for in a lot of ways.
So perhaps sort of,
Sam, would you like to? Sorry, go ahead. Go ahead, Martin. Sam, would you like to maybe share how people listening to this call can help the project and support the project, and how that matches with your priorities, like what we could help with and what you'd like to see over 2020?
Big question. Thank you. Probably an important one at the end of this. Yeah, I mean, I'm wearing too many hats. It would be great to have more Rust developers on the team who can work on the core stuff. But the UI project is kind of the bigger work, I think, in this next phase. It's sort of like, you know, there's rough edges to polish there, and the foundational tech it's ready to be brought into use cases and integrated. It's just not production ready yet. And a lot of that is going to be user interface and people building. Like the vision for it is really that you should have a whole bunch of very simple, very, you know, tailored apps that do useful operational stuff for people in different contexts. And all those apps function more or less independently, but they all contribute to this same interwoven web of data underneath that's rich and, you know, added to in different ways. And so people that, particularly impact assessment is kind of one of the bigger areas that I'm interested in taking this at the moment, because the more, you know, we've got this upper ontology that describes everything in tangible reality. So you can do a bunch of, you know, probably using something like Sacred Capital, do a bunch of derivation on that to answer a whole bunch of questions. Yeah, you, how do I put this? Hang on, let me put it a different way. The more impact assessment frameworks that we can satisfy with open source modules that derive from this core data set, the more languages there are that people can speak to big, you know, groups like the UN. They can talk sustainable development goals, or see natural capital accounting standards, or GS1 supply chain data standards, or whatever. So each one of those being built as an open source module really just amplifies the power of anyone that might use this to be able to have a voice in those conversations. And I think that's really important. But the much more important thing is finding the localized peer-reviewed grassroots certifications that are nuanced and place-specific. And again, tying back to the start of this, it's actually going deep into the carbon industry is kind of one of the bigger things that made me realize how this work, you know, the technology is kind of the easy part. It's the cultural attitudes that have to change, and the technology by itself is not going to really do a lot of good. In fact, if the technology is just put out there with no culture, colonial mentalities will come in, and patriarchal ideas will come in, and it will just, the great likelihood is that people look at this system and they look at this data and go, wow, that's what sustainability looks like. I can just replicate that everywhere and it'll all be sustainable. And that doesn't work. That's called colonialism. You can't have the same thing everywhere. It's not, you know. So yeah, there's a couple of groups doing interesting stuff. Like PGS India is one, these peer certified organic produce things. But there's heaps more. You know, the Global Eco Village Network has a really comprehensive impact assessment framework, and an amazing report that relates it to all other kinds of, you know, things like the SDGs and Bhutan's happiness index and all kinds of stuff. So I'm really aiming to support as many of them as possible, but I'm more aiming to empower every individual with the ability to create their own certifications, or their own reputation scores, or, you know, their own qualitative judgments about reality, basically. I think we're also going to wind up seeing a lot of AI in this. People are going to start throwing AI at it. So again, these things as being like human sense-making apparatus and human visible checks and balances are really important, so that the AIs don't just, you know, run rampant and do a bunch of things that oppress people without knowing that they don't really like. Yeah, and the goal that I'm personally moving in with the work is to just be more and more towards the marginalized ends of spaces in society, really. Because the more you work with people who are further down the privilege spectrum, you know, it elevates them as well as everyone above them, basically. And if you're working for privileged people, you're only really helping the privileged people. But it's also that those people are dealing with things on the edges of society that I'm fairly convinced we're all going to be dealing with in 5-10 years time as global society starts to collapse. You know, we're all going to be on the edges and the fringes. So finding people where that's the lived reality and working with them to be more resilient and off-grid and less connected to the global supply chain is really where the work is at for me now, I think. Yeah, and we'll try and get more formal about soliciting expressions of interest and opening up the doors and getting more engagement in this process too. There's definitely a balance to be struck between, you know, colonizing with language and going out and saying, hey, marginalized people, we want to work with you, versus letting yourself know, making it known that people can approach you and having them come if they've got projects they want to work on. But a lot of the governance and strategy thing is really important too with that. So those are the other contributions that I'm really keen particularly to get involved. And, you know, it's an intersection of things that there's not a lot of them. There's not many indigenous technologists in the world, because why would they be when technology has mostly oppressed and harmed them? So finding those groups so that we can sort of upskill them, and ideally so that they can build things that I have no understanding of because I'm not an indigenous person, would be an ultimate goal. And then, you know, it's more about systems that do things in nuanced place-based ways with local customs and culture and language, and having this maybe, if all goes well, as sort of a fabric that is, as best as we have, an objective reality about resources that can allow us to all speak between these communities. Sparkle fingers, yay. Cool, well, I'll leave it there. Thank you so much for all being here. For those that made it through the 2 hours, appreciate your time. And yeah, I hope it was worthwhile and reasonably informative and entertaining, and we'll try and do it again sometime as things evolve.
Thank you. Look forward to the recording.
Yep, I will upload it now. I'm going to save chat, do all those things, and push a video. So you will all see yourselves on YouTube soon. See ya.